Hey guys, hope everyone's healthy. Hope everyone's doing okay. Finding things to keep you occupied at home. It's crazy what a couple weeks will do to just everyday normal life. Hopefully, starting back in at school, but not too demanding. Hopefully, it'll give you some sense of normalcy and a little bit of a routine going, and it'll make life a little easier to cope with. For the rest of the semester, we were going to cover chapter 7, 8, and then about half of 9. We have knocked that down. We will only cover section 7, and then the last week or two of school, we will just review everything we've learned in the second semester. This is like my 10th time trying to record this video. I didn't like any before, so we're going to go with it. Mistakes are mistakes, guys. I'm learning it too. It's not going to be perfect, but deal with me. I'm on someone else's whiteboard, so it's not writing the same way as mine, so it'll take some getting used to, but we'll learn it together. With that said, we're going to start with 7.1. We're going to start with inverse variation. We'll also learn what direct variation is. So let's get started. So before we can do direct and inverse variation, the first thing we have to do is we have to understand what each of them are. Okay, so inverse variation is simply when y equals a over x and a is a constant. Remember, we've talked in the past about when we talk about something being inverses or inversely related, we're kind of like the opposites, the do and the undo. So once again, inverse here means opposite. Direct variation, on the other hand, is simply when y equals a times x, which should make sense. All right, let's do some examples of just how to identify what. Just from the slide before, direct variation, remember, was y equals a times x. And then the inverse variation was when y equals a over x. Once again, a is a constant. A can also not equal to 0. So notice when we're trying to figure out if it's directly or inversely related, we want to have an equation in terms of y. Y here, y here. So first thing we want to do is we want to change all these equations to terms of y. So xy equals 5. If we divide both sides by x, we'd get y equals 5 over x. As you can see, this is inversely related. So this would be inverse. And if we wanted to go a step further, our a would equal 5. All right, part B, we have y equals x minus 4. Now, if I look at this, it's already in terms of y, and it doesn't match either direct or inverse variations, so this would be neither one, and we can have neither. Okay, so part C, once again, let's solve for y. Multiply by 2 on both sides, we'd get y equals 2x. If we look up here, that would look the same as the direct variation. And if I wanted to go a step further, my a is 2. All right, so how are we going to use direct and inverse variations? First, we need to know how to, according to a chart, how to find if something is directly or inversely related. So what we do there, we kind of flip things around and we solve for a. So if it's direct variation, my a is going to be y over x. Guys, this should make sense. You shouldn't have to remember this, because remember, direct variation would be y equals a times x. And if we solve for a, I get y over x equals a. It's the same thing we see over here. Okay, so don't feel like you have to memorize this. Same thing down here. Inverse variation, guys. We have y equals a over x. If we solve for a, we're going to multiply by x on both sides. So we'd get x times y equals a, which is what we have right here. So once again, you don't have to memorize these. If you know the definitions of inverse and direct variation, you can solve for a that way. All right, so we're given 2 charts. Now, these 2 charts, we want to find if they are directly or inversely related, or they might be neither one. So on this first one, some of you guys can look at this and you can automatically see 2 times negative 12, guys, is negative 24. 4 times negative 6 is negative 24. 6 times negative 4 is negative 24. 8 times negative 3 is negative 24. So what we just did is I found that x times y is always equal to negative 24, okay? It's always the same constant. So if we go back, when we solve for a, which would be negative 24, a is always x times y. So this would be inversely, or inverse variation. Okay, so go to example B. Now, 1 times 2 is 2. 2 times 4 is 8. We can automatically tell by these two that it is not inverse variation. So we can pin that out right away. So now we have to check to see if it's direct variation. So if we go back, direct variation is a times y over x. Or a equals y over x, sorry. So now let's check. So y over x here would be 2 over 1. Here, y over x would be 4 over 2. Well, guys, this is equal to 2. This is equal to 2. So far, this is looking promising. Now, if I get to the third one, y over x is 8 over 3, which is not equal to 2. It's not equal to this and this. And therefore, it's not direct variation, and therefore this would be neither inverse or direct variation. All right. Now 2 words. Now we're going to find equations given that they are inversely or directly related. All right, so let's read this. The variables x and y vary inversely. So what that means right off the top of the bat, what we can get out of that is y equals a over x. Okay, and then it gives us y equals 4 when x equals 3. So we want to write an equation that relates x and y. All right, so I'm going to take this. Y equals a over x. Okay, first thing I want to do is I want to find my constant. I'm given y is 4 and x is 3. So all I have is my a in this one set of data. So if I plug in y equals 4 and x equals 3, I get 4 equals a over x. Now I want to solve for a. So bring everything else to the other side. Oh, x equals 3, not x. So multiply by 3 on both sides, I get 12 equals a. That's not my final answer, but that's definitely what I need. So when I plug my a in, that means, because a is a constant for everything, that means y is going to be 12 over x. Okay, so this is the first part of it. This is write an equation that relates x and y. That's this y equals 12 over x. Now it says find y when x equals 2, guys. As you can probably tell, all we're going to do is plug negative 2 in for x. So I have y equals 12 over negative 2. So y then would be negative 6. Okay, so in this equation, an ordered pair would be what? Negative 2 and negative 6. I get that from here and here. All right, example number 4. This is the last one. Guys, this section's kind of short compared to the others. I would guess most lessons will take 15-ish minutes, but I don't know. This is the first one of all of them. That's just a guess. So, word problem. The time t in hours that it takes a group of volunteers to build a playground varies inversely, keywords here, with the number of n volunteers. So we have n and t. All right, so first of all, when I talk about varies inversely, that means y equals a over x when x is some constant. Now, this isn't talking about x and y's, this is talking about t's and n's. So all I'm going to do is I'm going to change this equation here from x's and y's to n's and t's. So I can also write this as T equals A over N. Did we have to do that? No, but this word problem is talking about T's and N's. All right, so T equals A over N, where A is some constant. It takes a group of 10 volunteers 8 hours to build the playground. So 10 volunteers. Guys, volunteers is your N. Oh gosh. Volunteers is your N. 8 hours is your T. So if I plug this in, I would have T equals A over N, or T, which is 8, equals A over my N is 10. Okay, I want to solve for A. So multiply by 10 on both sides. 80 equals A. Okay, so to find the equation, I would use Y is always going to equal my A is 80 over N. Oops, Y should be T. T equals 80 over N. All right, so make a table showing the time it would take to build the playground when the number of volunteers is 15, 20, 25, and 30. All right, so in volunteers, T times, we want 15, 20, 25, and 30. So 15, 20, 25, and 30. Okay, guys, we've done all the hard work. All I'm going to do now is I'm going to plug this 15 up here to get my T. So T equals 80 over 15. What is that? 80 over 15, I get 5 1/3, so 5 1/3 hours. Or that's the same thing as 5 hours and 20 minutes. All right, so next, what happens when my N is 20? So T equals 80 over 20. Well, that's a lot easier. It's only going to take 4 hours to build the playground. All right, what about when it's 25? So T equals 80 over 25. I get 3.2, which is roughly 3 hours. 0.2 is what, 1/5, so that'd be 12 minutes. Or just 3.2 hours, whatever Big Ideas wants. And last but not least, what happens when I have 30 volunteers? So T equals 80 over 30. That gives me 1.2 hours. Is that right? 80 over 30. Let me get my calculator. No, that's not right. That gives me 2 2/3 hours, which is 2 hours and 40 minutes. All right, so last question, what happens to the time it takes to build a playground as the number of volunteers increases? Well, as number of volunteers go up, the time, scroll down a little, it takes to complete the building of the playground goes down. All right, that's all for this section. Make sure you do your Big Ideas homework. And once again, if you have any questions, feel free to reach out via email. Adios.